Finally, okay, this is our Learning Bitcoin and Design session here with the Bitcoin design community. This is kind of a sequel to last week's call, which was called the Lightning Primer for designers. And there was just kind of a consensus on the call that people wanted to be doing more of these kind of learning and discussion group types of content. So I went ahead and scheduled it again for today under a more generic title so that we can just kind of keep reusing that call title into the future and just have a different topic depending on what people want to learn and talk about. And yeah, this week, Millie posted some questions in the Slack regarding this call about Lightning and stuff. And I decided to just take that and run with that as this week's call topic because it seemed like good information for everybody to know as they're starting off with Lightning. And let me go ahead and paste a link here into the chat for everybody to see, and then I'll share my screen here. And then wait, that's not how I share a screen. I need to go to this button over here. There we go. Yeah, awesome. So I kind of generalized Millie's questions a little bit and put them into these like yellow sticky note cards. And some of them, like the ones that I have over here on the right, I felt like there were pages in the guide we might be able to look at and read through to talk about. But there's two questions that I thought were really important that I don't really think we actually have reflected in the guide. And so I just went ahead and did kind of a stream of consciousness explanation of it. And disclaimer as always, I'm not, the definitive expert on this stuff. This is my current understanding, but I figured I would just go through and just kind of go through some of these flows and kind of explain how some of this works. And then if anybody has questions, you can just jump in and interrupt me and ask me. Does that sound good? Does anybody have any questions before I get rambling here?
Please ramble.
Cool. So,
Sounds good.
So important question is kind of like, what's a good way to think about channels? Does a merchant need to close their channels to collect their money? Because last week we kept talking about the Alice and Bob scenario, and what if Bob's running a coffee shop and got channels open and stuff like that? Does Bob need to close his channels to collect his store's revenue? And so here's my kind of response to that. So like I just like to think of the Bitcoin blockchain as a big giant ledger that keeps track of all the coins in existence. And when I say coins, again, I'm using that word so that we don't have to use the really unfriendly term, which is UTXO, unspent transaction output. I'm just going to say coins instead, because I think that's a little easier to understand. A coin is just a kind of a discrete unit of Bitcoin that's recorded in the ledger. So the blockchain is just a big ledger, right? So owning Bitcoin means that you have the ability to go to that ledger and spend coins that are on that ledger. That's what ownership means in a technical sense. In a legal sense, ownership is probably going to mean something very different depending on where you're located in the world and what the laws are there. But in a technical sense, it just means you can go to the ledger and you can spend that coin there. That one's mine. Actually, I don't even think it's right even to say that it's mine. It's just to say I have the ability to spend it. So like, what are some different ways you could have the ability to spend Bitcoin and therefore technically own it? So I think like the simplest way is the one we're probably the most familiar, which is this idea that I send a coin to an address and I own like you send a coin to my address, I own the keys that are associated with that address, so I therefore can spend it. So on my phone, I have a private key to this Bitcoin wallet, and any Bitcoin that goes to an address that my phone generated, I get the key to spend that Bitcoin. So it's like the simplest way of spending Bitcoin. And then we might think of like a more complicated example. And so like instead, I have a multi-sig address and you send the coin to me and it's a multi-sig controlled by 3 keys. And maybe these are hardware keys or hardware devices that hold the keys, right? Or maybe one of them is on my phone and 2 of them are on hardware devices. It could be set up any number of ways. But then this is different. I still own the Bitcoin. I can still spend the Bitcoin. But in order to prove that I can spend them, I just need 3 different keys. Okay. Let's take it a step further. Then let's say I've got a multi-sig setup with my family, and I own one of these. I own the cold card, and different members of my family own, the treasure or the ledger or the foundation. So it's like a family vault for some reason, and it requires two of these keys in order to spend funds. So that means that I alone can't spend the Bitcoin. And neither can, like, let's say my uncle, who I guess owns the ledger, but collaboratively we can own it together, we can spend it together, or two other members of the family could collaborate and spend the coins. So this is a situation where, like, ownership of Bitcoin becomes a little more nuanced. It's not the same. It's a much different scenario than just I own the keys, so I own the coins. um, so then let's take that a step further and, like, say, well, how would that look on Lightning? So when you are on Lightning, all you're doing when you're forming a payment channel, you're basically forming a multi-sig setup between you and your channel partner. So, like, let's say, we've each got our Lightning nodes here, and we formed a payment channel together, and we really put them into a multi-sig vault and a multi-sig like an address, right? And so we're kind of collaborating together in order to manage these funds. Now, the important thing to remember is that, like, these funds in this multi-sig address are not just it's not just that both of us have to consent in order to spend the funds. There's some additional stuff going on inside of the locking script. There's basically a smart contract that kind of has some additional rules. It's like we can spend the funds if we both create a transaction and we both sign it. So me, or let's say Alice and Bob, collaboratively um, have to choose to spend the funds. Or there's some other kind of stuff, like, let's say Bob goes offline or Alice goes offline. Bob wants to close the channel. So he can go ahead and send a transaction without Alice's consent, but he's going to have to wait 2 weeks to get the money. And then there's kind of a way that if Bob tries to cheat on that arrangement, Alice can go in and kind of commit a justice transaction. So I don't want to get too deep into all that right now, but the point is that ownership of coins in a Lightning channel is, it's kind of like just this whole evolution I've been showing you, is that ownership of Bitcoin is not just as simple as owning the keys. You can also have these kind of highly customized financial arrangements. And that's exactly what a Lightning channel is. But because they can collaborate together to manage the funds, and they have these kind of smart contracts that protect them in these different scenarios, they basically can be confident that any transaction that they create off of the blockchain and pass between each other, they could take that transaction at any time back to the blockchain and cash it out and kind of get their money. So you have to think about it. If I have a transaction, if I have a key here, a private key on my phone that allows me to spend coins, or I have a signed Bitcoin transaction, which I'm holding off of the blockchain, say on my computer or something, I have the ability to spend the coins either way. So they're in a technical sense, they both count as ownership, right? So that transaction, can be cashed out anytime. So the way I think about it is that you can consider Bitcoin inside of a payment channel to be just as good as Bitcoin that's not in a payment channel. As long as you have the ability to spend get Bitcoin, it's basically as good as Bitcoin. Doesn't matter whether that it's a payment channel or not, as long as you have the ability to spend it. So if you think about it from that perspective, um, what's wrong with keeping Bitcoin in a payment channel? Because Bitcoin in a payment channel gives you access to the same valuable asset, Bitcoin, but it gives you improved liquidity. You can send it places quicker and faster and with lower fees. So, I think that that was a long-winded way of building up to answering the question, but I thought it was important to understand that, the decision to take Bitcoin out of a payment channel, I see as more of a technical infrastructure decision. So it's like, oh, this channel partner is unreliable. Their node keeps going offline. So I want to, close out the channel and start a new one with somebody I can trust better, or that I can rely on better. Oh, I've made so much money on this Lightning channel. I want to move some of the funds to cold storage, just to keep them offline, make them safer, that kind of thing. Or I want a channel with even more funds in it. So I'm going to start a new channel, right? these are all like kind of technical infrastructure reasons why Bob might close the channel to manage his Lightning node better. But he doesn't have to do it because funds in a Lightning channel, that's Bitcoin that's just as good as funds that are not in a Lightning channel. So I think, there's a paragraph I linked to in Mastering Bitcoin. It's like a couple paragraph or Mastering Lightning. It's a very technical book, but this like one paragraph, this like handful of paragraphs that I describe here kind of goes over what I was just talking about, worded differently, and that's where I got the inspiration for all of this. So long-winded way of saying it, but that's just kind of it's good to just think about Bitcoin in a payment channel as being just as good as Bitcoin on chain. Any like thoughts or comments on that? Cool. Hey there.
Yes. Okay. Sorry, I might be like very trying to understand in like layman's term. So when you say it's an infrastructure decision, like in a merchant life, like day to day, how he would like never close his channel, basically, like.
Probably not.
Okay.
Now I'll go ahead and say I was using Alice and like I was using the Bob as an example just to put like a kind of a human
Yeah.
face on it. But really, I think in the future, people like merchants probably aren't going to run their own Lightning nodes. They're probably, maybe if they
Yeah.
work for maybe if the store's a very, very big company, they might. But I think most people will outsource that. But yeah, I don't think they ever need to keep their payment channels. I don't think they ever need to close their payment channels.
Okay. All right.
Unless they
Well,
want to. But
yeah. Okay. I didn't think like that, but all right. I learned something new. Thank you.
and I'm looking for brutal feedback here. Did I fry everybody's brains with this stuff, or like was this a good simplification of it, or a rough kind of a bad simplification?
It was a very good. No, I think it was a good simplification. Simplification. Oh, okay, my brain is fried. No, I also have another question if you have a moment.
Yeah.
This is this one part here that I don't understand. I'm just looking at the diagram. You said that in a Lightning payment channel, it's also possible to have like multi-sig as well, if I heard correctly. So like, can you explain a little bit about that? Just like in more, re-explain or just so I can understand it.
Yeah. So this kind of touches back onto a little bit of what we were talking about last week. So I'll bring a sticky note back. So like, basically, this will probably ring a bell as soon as I start typing it in here. So basically, in order to fund it, let's just like assume the situation that Alice opens channel to Bob. Okay. So what that means in today's world is that Alice is funding the channel. Okay. So what she's going to do is, the two nodes, Alice and Bob, are going to talk to each other here. I'm going to label these as Alice and Bob just for simplicity. I didn't mean to put a bullet there, but whatever, we have a bullet now. And so Alice is going to, they're going to send some message. The nodes are going to send messages back and forth and kind of negotiate what this looks like. And then they're going to fund the channel. And what that is it's just a Bitcoin transaction that gets sent to the miners and gets included in the blockchain. And this is going to be a special Bitcoin transaction. It's going to be a 2 of 2 multi-sig transaction. And Alice is, provides 1 sig. And then I'm going to simplify that as just sig. Bob provides other sig. So obviously this would be written in computer code, but I'm just kind of translating it into plain English here. So you basically have this transaction, and what it does is Alice's money goes into it, and it's like, again, let's say it's like a million sats. And so the transaction basically says Alice gets 1 million sats and Bob gets 0 sats. And so if they want to basically spend, so this is now basically these funds that Alice put in are locked in what we call a multi-sig address. So let's go ahead and type that out. Alice and Bob's funds. Technically, they're just Alice's now, but we'll just say Alice and Bob's funds are in a multi-sig address, right? And so every time they make a Lightning payment, all they're doing is they're just advancing the channel state. And so if Alice wants to send him some money, it's going to be like, okay, oh God, I have to do math now. Let's say she's just sends him half of it because I don't feel like doing simple math at the moment. I'm sorry. So she sends him 500,000 sats, and all they're doing is they're just creating a new Bitcoin transaction. And because it's multi-sig, they both have to sign off on this transaction. They both have to collaborate on these transactions. She eventually, sends him some more money. Every time they make a new Bitcoin transaction, they advance the channel state. Eventually, she sends him the majority of the money in the channel, let's say. I'm going to let this be the last one. And then at that point, if Bob decided to close the channel, he could do that by creating a new transaction. And then the funds Bob would get 850 out of it. Alice would get 100,000 out of it. Is that kind of what you were looking for?
That's perfect. I understand. Thank you.
Cool. Any other questions on this topic before we move on to the next question?
There are 2 raised hands.
Sorry, I can't see that where I'm at. Let's see.
I have a question.
Go for it.
Okay, so let me formulate this. Okay, so then why people say that in order to collect the money, they need to close the channel then? Is it like a general misunderstanding or?
It's a good question. I'm not sure who these people are and what the context is. I don't know what the situation is that they said that. So I would say that, for some people, there is definitely a misunderstanding. They feel that how am I trying to say this? It's kind of a philosophical question. There are some people who think that Bitcoin in a Lightning channel is not real Bitcoin. I disagree with that view, but that's their opinion. Yeah, but my viewpoint, and I'd say the viewpoint of many people who spend a lot of time working on Lightning, is that Bitcoin in a Lightning channel is just as good as regular Bitcoin. But having said that, there are security implications to consider. So, this channel, this comes with trade-offs, right? Bob and Alice's node have to be constantly monitoring what's going on with their channel partner. They have to make sure that their channel partner isn't trying to cheat on them, let's say. So for some people, let's say, Bob has all this money right here, and then Alice tries to cheat by sending this one to the miners. And there's a way that Bob can prevent that, but he has to be actively monitoring for that. And if Bob goes on vacation for 3 weeks and his node turns off in a thunderstorm the day after he leaves, he's probably going to lose all the money in that channel. So there's definitely a feeling of security and greater ownership, I think, when it's not in a Lightning channel. I would personally say I wouldn't put my life savings in. I wouldn't have my entire life savings in Lightning channels. But if I, for a daily spending wallet, I keep money in Lightning channels, to make, daily purchases. That seems reasonable. If you're a large business that does transactions with thousands of people all across the world, it makes sense to have a lot of money in Lightning channels. But if you're talking about security and life savings, that maybe is best kept at our current level of technology. That's better maybe kept off Lightning. So yeah, hopefully, I'm not sure exactly what those people said, but hopefully that gives a broader perspective.
Okay, yeah. Okay, then just a follow-up question.
Yeah.
So when you open a channel, you need to do a on-chain transaction to have that 2 of 2 multi-sig. I've read somewhere that it was saying, yeah, so that it was saying you can open a Lightning channel by creating a Bitcoin transaction and unlock them in the Lightning network. This ensures that money cannot be spent at multiple places. So let's say I open a channel with 1,000 sats, but I need to pay someone above 1,000 sats. Like, I need to put more money on my channel then?
That's the central issue. Yeah, that's a very good question, and that's kind of like one of the central things that we struggle with in Lightning, and I think that's called liquidity. And it was funny, me and Christoph and Bosch and some others were just talking about this on a call the other day about how we might actually need a page in the guide that just kind of explains the concept of liquidity to designers. But yeah, it basically means if you open a channel to me and you fund it with your Bitcoin, then you have, let's say, 1 million sats of outbound liquidity. So it means that, if I could resort back to drawing for a second, yeah, I mean, it basically means like if I make a card for each of us here and you open a channel here, and then I connect these together, and we'll say that, this is 1 million sats, and it goes, it's on Millie's side of the channel. So that means you have that much liquidity. But as soon as you send it all to me, then you have 0 on your side of the channel. So you have to get liquidity. So a lot of times what other people will do is, they'll get other nodes, like, an example. I don't want to go too deep into this right now because this is a deep topic and I want to get to some of the other stuff you asked. But like, this is where there's room in the market for like places like, the Dunder LSP and other services where you could, open up a channel to another node, and then you'd have even more liquidity. Or it could be the other way. It could be that they open a channel to you and give you liquidity so that you can start receiving. So it's like you need liquidity in both directions. You need outbound and you need inbound liquidity.
Yeah, and if you want to send more than 1 million sats, if you want to send 2 million, then you just have to open another channel. A channel cannot be changed. You cannot just add more Bitcoin to the channel. You have to open up a new one or close the first one and open up another one again.
Yeah, good point to bring that up. Yeah,
okay.
That might change in the future, but right now that's the way it is.
All right, thank you.
And then I think Roz had a question.
Yeah, you guys kind of just answered my my question. One other thing that I wanted to ask, actually, if you would have right now we're looking at a simplified channel where we have just 2 elements. If we were to have a third party there, a third person that let's say we have Alice, we have Bob, and then we have Charlie that wants, we have Alice that wants to send money to Charlie. Does that mean that for each transaction, then we're going to have, for example, if we want to send 1,000 sats from Alice to Charlie, we're going to have Alice and Bob both verify the transaction, and then we're going to go to the next part of the channel, and then we're going to have Bob and Charlie verify the transaction. I think I made that over.
No, I think I see what you're saying. Yeah, I mean, so basically, that's what I would call. I think there's some noise coming through in your mic. Would you mind going on mute for a second? Thanks. There was just a lot of noise going on. I was picking up. I'm going to like try and just that's exactly right. I mean, basically, Alice and Bob. When Alice wants to send money to Charlie, Alice has to route it to Bob, and then Bob has to route the money to Charlie. And so there's a lot of back and forth, and it can get complicated because you can have you could have a route that goes through like 18 nodes if you wanted to, and so it gets a little bit. The reason I sound distracted is because I'm actually scrubbing through the pages of Mastering Lightning, because there's like some diagrams in some of the later chapters that I think explain it really well. And I'm just going to copy that to my clipboard. I'm just going to paste it here into the Fig Jam. But yeah, I mean, it's like you run into complicated scenarios like that, like, kind of to Millie's question about liquidity. Alice wants to pay 10,000 to Dina, but there's not a direct channel, so she has to route it through these channels here. And so it actually, if she's able to do that, depends on the liquidity in these channels. She's got 70,000 on her side, and there's 30,000 on this side. So it totally depends on how much funds are locked into channels, and can she find a path? And as for how that happens, yeah, she passes it to Bob, Bob passes it to Chan passes it to Dina. The exact mechanism by which that happens is called HTLCs, and I don't want to get into that too deep on this call because it gets pretty complex. I will drop a link to like a chapter that basically describes how it works in excruciating technical detail. But yeah, but effectively she does have to route it through multiple nodes.
Okay, that's quite clear. Thank you.
And Magashni, did you have a question about this before we move on to the next topic?
Yeah, very quick question. Can two people fund a channel? So like the example that you gave is just Patricia funds the channel, but can Patricia and John fund a channel and then pay Thomas simultaneously?
Can they? What do you mean? Can they fund a channel and make a payment in the same like in one action?
Yes.
I don't know the answer to that, and I mean my intuition is that it's hard to call anything in Lightning like one action, because when you start studying the protocol, there's all kinds of like negotiation and messaging. Like there's this whole thing called Lightning messages. It's just like a way for nodes to like talk to each other and negotiate back and forth. So like, when we say opening a channel, really there's like 50 things happening. It's like, one node asks for this and the other node responds, and it's like a whole process. So now, could that be simplified on the user experience layer to where it seems like a point and click thing? Yeah, sure. I see why not, as long as someone's willing to write the code to do that.
All right. Okay, thank you.
And to give it to kind of summarize that, to finalize that topic real quick, I think Breeze kind of does a little bit of that already, because you can receive your first payment on Breeze, and Breeze will open a channel to your wallet. They don't even tell you. I don't even think they tell you that they're opening a channel, or it's real user simplified message. But so I think that, I think what you're describing should be technical. It's just a matter of if you can get the developers to write that code and get the designers to build a good UX on top of it. Okay, I'm going to move on to the next question that Millie posted in Slack, which I thought was really good, which is, what is the difference between a Lightning node and a Bitcoin node? And I couldn't also find like a concrete, clear differentiation between these two in the guide, which I'm kind of wondering if we need, because these are terms that fly around all the time when we're talking to developers, and it sounds like they're the same thing. I mean, they both have node in them, but they're not. And so it's probably good to just have like a simple explanation of what each one does. So I think of a Bitcoin node very simply as it's just a computer that holds its own copy of the Bitcoin blockchain. Simple as that. Got my cute little blockchain icon art here, built from the Built Bitcoin Icons kit. That's a blockchain. Okay, so Bitcoin node's a full participant in the network. Since it has its own copy of the blockchain, it can share transaction data with other Bitcoin nodes. It can validate blocks. It's good stuff. This is like what a Bitcoin node looks like. This is Bitcoin Core. It's this piece of software hasn't changed that much visually in the past decade or so. Though I know that there's people working on that, but you can go to bitcoin.com. There's probably a download link for this software. You can get it running on your Mac in probably 5 minutes, and it's going to be like doop 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 downloading blockchain. And if you don't have enough room on your hard drive, turn it off before it finishes. But that's it. It's basically just a computer that runs this piece of software. That's a Bitcoin node. So you got to say, well, why would you want to run a Bitcoin node? What is the purpose of it? I think for a wallet, having access to a Bitcoin node is very critical, because a Bitcoin wallet has to ask questions like, are there any coins on the Bitcoin blockchain that I can spend? Is anyone trying to send me Bitcoin? I sent somebody Bitcoin yesterday. What is the status of this payment? Did it reach them? Et cetera, et cetera. And a node can answer all of these questions for the wallet. In fact, I would go as far as to say that only a node can answer these questions for a wallet. A node, because it has a copy of this, it is kind of like the definitive source, as definitive as you can get. It's the most definitive source of truth about what's going on Bitcoin. So a node is basically required. A wallet relies on a node in order to be able to tell what's in the wallet. So like one thing you could do is you could run a full node and a wallet software together on the same computer. And that's kind of what Bitcoin Core does. It will actually let you run a wallet and a node together. Most people don't do that in their daily lives. So if you've never done that, then don't feel like you're missing out. It's not, that's, you know, for much more technical users, but that would be one way of doing it, where you've got the node and the wallet on the same, they're effectively the same thing. You know, another thing you could do is you could have a Bitcoin wallet, let's say on your phone, and it connects remotely to a full node. So I don't have a handy graphic prepared for that, but just imagine here where my mouse cursor is that you've got the little phone graphic, and then imagine there's like a little, you know, dotted line that connects it over here to this thing. That's, you know, that's all it would have been. And then, you know, there's other more novel ways of doing it. There's modern techniques where a wallet running on a phone can kind of get less data from a node, essentially. Like, it doesn't need all the blockchain data. It just needs to kind of get like block filters and stuff like that. So let's leave the excruciating detail behind there and get into what a Lightning node does and like how that relates. So a Lightning node, I'm going to move tidy up here. It's like kind of bugging me that I've got all this stuff right over here. So a Lightning node is, you know, basically what forms payment channels with other nodes. It's like, you know, Alice and Bob and Chan and Dina that we were just talking about. Those are Lightning nodes. So Lightning node activity is going to happen mostly off of the blockchain, but a Lightning node is still going to have questions about the blockchain. Has my payment channel opened? You remember we talked about this, and Alice and Bob need to open their channel by creating this transaction. Well, that's got to close on the blockchain. So the Lightning node needs to ask, hey, has this opened? Or, hey, has Bob closed the channel on me? Is my channel partner trying to steal my money? Other stuff that's way too advanced to talk about at this point in time. And just like with the regular old Bitcoin wallet, a Bitcoin node can answer these questions for a Lightning node. It's the only thing that can answer these questions definitively. So therefore, a Lightning node must always be able to talk to a Bitcoin node in order to do its job. So here, handy graphic. Always remember this. You got your Lightning node, you got your Bitcoin node over here. It's really just a computer running this piece of software. It's got a copy of the blockchain. The Lightning node is going to ask it questions. These kinds of questions right here. So there's a couple different ways you could do this. And, you know, I'm going to go down, like start with kind of, you know, some of the ways you wouldn't see ordinarily, and then get to what the kind of stuff you would see. So like one way is like an enthusiast might run a Bitcoin node and a Lightning node together on dedicated hardware. So I think this machine actually runs the Umbrel operating system. Basically, all it is they've just put a Lightning node software and a Bitcoin node software, and they're just running them on the same device. And so the Lightning node, when it has a question about the blockchain, it doesn't have very far to go to ask that question. Another one might be, whoa, I've got a hand on my mouse cursor. What's going on? Okay, it's gone. Another, you know, example is like, let's say Bob's Coffee, you know, makes so much money, it goes public, it becomes the next Starbucks, and, you know, they're just running a lot of Lightning nodes because they're selling a lot of coffee over Lightning. So maybe they do something like, well, they have one company Bitcoin node, and then they've got, you know, different Lightning nodes and different, you know, for different purposes within the company, and they all talk to the same Bitcoin node to get their data from. You could do that too. But what's probably going to happen to most people in their daily lives is they're going to have like this easy to use Lightning wallet, and there's actually going to be a Lightning node running on the phone itself. It's going to be a piece of software like LND or Eclair or something like that, or LDK or something like that. But it's just going to be a piece of Lightning node software running on the phone, and then it's going to connect remotely to a Bitcoin node. And different wallets have done different things. There's, you know, some of them use this new neutrino thing. Others, might just connect directly, like Electrum or something like that. There's different ways of doing it, but that's basically all it is. And so, I think like several of us have been on the Blix design sprint. So I think if you open up your Blix wallet and you go and you dig down into the advanced settings, there's like the network info, and there's actually an address that tells you which Bitcoin node it's connecting to. I think it's like node.blix.com or something. I can't remember. But so when you see that, next time you open Blix wallet and feel like digging through the menu, that's what's happening. It's connecting to that so that it can ask these questions. So we do have a page on the guide that goes into like a little bit deeper into some of the just different types of arrangements and configurations for nodes, but I didn't really feel like it answered the question as succinctly of like what's the difference between a Bitcoin node and a Lightning node. So that's why I threw together these graphics here. All right, did that work or did I fry some brains?
It worked.
Brilliant.
No, thank you. Any questions from anybody on this one before we move on? I don't want to rush us. Okay, sounds like everybody's doing good, so cool.
Yeah.
So I'll go ahead and say, yeah, we've got probably about 20 minutes left here, and I don't know that we're gonna have time to get into all of this. You asked kind of about how Dunder LSP works, Millie. I don't, Hampus would be the better person to ask about that, because I think he built it, right? But I could. We have some stuff that's going into the guide about Lightning service channels, and I'll tell you what, Bosch has a pull request open right now where he's writing a page about Lightning service providers. So I might steer you and anyone else who wants to learn about that to these links right here. So this one is the actual pull request where the conversation is happening on GitHub. And then this is actually like a deploy preview link that shows the page. So it'll look like, here, I'll open it just to give you an example. It'll, yes, I do want to leave Figma. Well, actually, you probably can't see it because I'm not sharing a browser screen right now. But if you click the link, you'll see that it looks basically like the Bitcoin design guide. It's just a deploy staging preview that we look at when we're reviewing things. We want to see how it's going to look before we take it live on the website. So one thing that might be good is you could actually read that page if you're curious and just see if that answers some of your questions about what LSPs do. And if it doesn't make sense, you could leave a comment on the PR, and Bosch could edit some things. I think what I might do now, though, instead of lingering on the LSP topic, is go to you were kind of asking about Bolt 11 and Bolt 12 and like Keysend and what's the difference between all these different formats. So I dropped a link here to the payment request formats page in the design guide. And I think I might actually now I will switch. I'm going to switch from Figma over from sharing my Figma screen to sharing my browser screen. And then we could dig around in this page. Let's see. Window, close. Yeah, so can everybody see my screen okay?
Yeah.
This is on the design guide live right now. You can get to it by, you drill down into the payments, requesting Bitcoin, and then go to payment request formats. And I think Christoph or Bosch, one of them put this page together. And this just kind of go, you did? Awesome.
I hate this page. It's so painful.
You hate it? What do you hate about it?
Well, just that this exists, it causes so many problems, right? It's kind of like there are these competing standards because the technology is evolving, and then every standard has like its own unique little properties. Like there are 3 things that are kind of called addresses, but then each of them, although they are all called addresses, like they're actually really different things, and they behave slightly differently. and you have to treat them differently in a user interface, and their names don't make sense to everyone. I mean, they're all kind of needed, and they're going to take us where we need to go, because they address UX problems. And they need to be there for to have a really good experience and like smooth transactions. But we're just kind of in this weird middle point where it's just really complicated, and things are not implemented in the same ways. You have wallet interoperability problems, and they're really hard to wrap your head around and to explain. So
Yeah.
this is one of the really painful parts about Lightning, trying to figure out how to allow users to deal with this in an elegant way.
Yeah, I agree. Like it's good that you assembled all the data, but it sucks that we're in the situation where we like need to worry about all this stuff at the moment. I mean, I would, so like, here's an example, like when you're looking at some of these payment formats, what they look like. And, obviously like the one that looks like the most simplistic is Lightning Address, but the rest of these are all, indecipherable by a human. They're all encoded, in like Beck32 or formats like that. So they're very difficult to parse, but I'm curious to see what happens. Like if I go in and take this, is this a real Lightning invoice, Christoph?
Usually I take real ones and then I modify some characters. And so it might not be able to decode.
Oh man. Hey, no, it works. Yeah, so basically what I've done here is I've just put this into the Lightning decoder. I think Andre from Zebedee made this thing. I put it in here and basically decoded it into something a human can understand. And it's like, this invoice basically contains like, hey, here's the public key of the node that you're paying. And this is the amount that you're required to pay or requested to pay. Right now it's set to 0, but could be, set to whatever. There's some other, specific, details in here that are needed. There's a timestamp, probably an expiration in here somewhere. But that's basically it. So it's just a data object that tells the two nodes how it is, like who you're going to pay and kind of how you're going to do it. But these things are unique for every single payment interaction. That's kind of one of the design challenges of Bolt 11, Millie, is that basically you can't use this invoice more than once. There's security risks if you use the same invoice more than once. So a fresh invoice needs to be created every single time a Lightning invoice takes place, which creates kind of like a user experience problem, because you have a situation where like what happens if I want to pay somebody and they're on the other side of the world and they're asleep, right? And I can't pay them because they're not there to generate the invoice. So Bolt 12 kind of goes into tries to solve that problem. Bolt 12 is still being discussed. It's still being implemented. It's kind of an evolving situation, but Bolt 12 is this thing called an offer, which is basically where it allows a Lightning node to, like, if the user scans a Bolt 12 offer, what happens under the hood is their Lightning node kind of asks the other Lightning node, hey, can you send me an invoice for this amount of money? So it solves the problem of people needing to manually kind of create invoices for each other. And it does a lot of other cool things too. I think you can go to the website and you can kind of see, like, I don't want to go into like the excruciating technical detail, but there's like a really nice page on here that has some examples and they tell you what they do. So it's like simplest possible offer, no amount specified. So this QR code, if you scanned it, would give you an invoice to pay. And then this is an offer that will give you an invoice for a fixed amount of money. There's one, I think, that asks you for a certain amount in dollars instead of Bitcoin, or you could do it for euros or whatever currency. So there's interesting things that Bolt 12 is going to do, but it's still kind of being built.
Yeah, and the big thing is that QR code will work today and tomorrow and next year, because the offer really it basically just includes the contact information for a node with some other details. And then your node actually gets a Bolt 11 invoice to actually make the payment. But the invoice always expires. The offer can stay around forever, so it's super helpful for donations and other kinds of use cases.
Yeah, that's a good point. Thank you. Yeah, because I guess with Bolt 12, you could just generate a QR code and put it on your website or on your Twitter bio or whatever, and it would be good. Anyone in the world could use it, and it would be secure.
Yeah, we could go quickly through the other ones if that's interesting.
Yeah, sure. I would say I might just mention Keysend real quick, just because that was one she asked about, and it wasn't, and it's not here, but which is fine by me personally. But Keysend is basically a way. I don't want to sound like I'm totally opposed to it. I guess I don't know enough about it, and I guess I'm skeptical due to my lack of knowledge. But it's basically a way where one node can send directly to another node without an invoice. It's basically like if you know the address and the public key of the node you want to pay, you can just send funds directly to that node without needing an invoice. But the kind of main caveat of Keysend is that you have no proof of payment. You have no proof that the person received your funds, which may not be a problem if you don't care about that. But personally, I kind of I think it's good. I think it's good user experience to be able to provide proof of payment. And so that's why I'm not really a big fan of Keysend as a result of that. I think that even if a user may say they don't care about proof of payment, but I feel like you're kind of putting them in a bad situation. What if they need to prove that they made a payment later on down the line? So it's just it's kind of one of those ideas that I'm like, well, I'm glad people are experimenting with it, but I'm just not personally sold on the idea at this point in time. Do you want to go through some of the other ones, Christoph, and just go through some of these maybe?
Yeah, sure. So Lightning AMP invoice, it's just a different type of invoice that's a little bit smarter in terms of the way it does routing. It can split payments across multiple routes and just using the one, which can be a little bit cheaper and faster, I guess, especially for big payments. The Lightning node ID, that's directly the address of your node, right? So if you, like Steven said, if you have Keysend, you just need the Lightning node ID and say, okay, I'm going to send you something. LNURL is kind of important. So LNURL is kind of similar a little bit in a way to what Bolt 12 does, except Bolt 12 does the same things over the Lightning network, while LNURL does it over internet, with regular internet traffic, basically HTTP or S. So it's there's always there's your node, then there's a server, and then your wallet talks to the server, which then talks to your node, right? There's this intermediary that handles the invoice generation. So it allows you to also have a static QR code that you can request multiple payments from or make multiple payments to. But it's there's this middleman, this middle server there. While with Bolt 12, you can kind of get the same thing, but just without this middle man there. But Bolt 12 stuff, that's all spec. It's not rolled out. It's not finalized. So that's why LNURL is a pretty great intermediate solution at the moment. And you can do things. You can request payments. You can make withdrawals. You can authenticate with it. You can request a channel open. It's pretty flexible. But my guess is long term, it will be replaced with all the things that will be coming with Bolt 12.
Yeah, and then Lightning. Sorry, go on.
And Lightning address is actually something that's built on top of LNURL. It's like a simplification in a way of LNURL that just gives you this simple identifier. But under the hood, it's all LNURL. If that makes any sense. But I don't think it makes sense. I think it's super confusing. I'd be surprised. You took me for, I don't know, Steven. I'm sure it took you also forever to wrap your head around these things, especially because there's no really good explanation somewhere. You kind of have to gather these from different places.
Yeah, it's been a process over the past year, I'd say. Yeah, I mean, it's like I've had to do a lot of deep diving and like reading every single day and all of that. So yeah, it takes a long time. You can't find the information about all of these things in one place. That's kind of the thing about it. You had to like, if you could learn about this from reading Mastering Lightning. You would have to go to Rusty Russell's website, to find the info on this. You'd have to go to the Lightning Labs website to find the info on that. You'd have to go to the LNURL repository to find info on that. So the information is definitely all over the place, and it can be very, very overwhelming when you're coming into it.
I think the main point is that with the stuff that you get out of the box with Lightning Networks are just these basic Bolt 11 invoices, and you just can't create a really smooth experience around that. So all of these other things that are being added on, they're just there to kind of fill in, just like LSPs, they're there to fill in some of the gaps, to make it easier, more seamless, more convenient, to have more possibilities like static QR codes. And each one of those things addresses something and everything does it in a little bit of a different way. Well, yeah, were there any questions around that stuff? I mean, I always feel stupid looking at this, so I'd be surprised if everybody got this right away.
I think I'll do some research on my own and probably gonna write you some questions because I mean I feel we could stay here for a long time if I start asking questions. So I start doing some research to know a little bit more and fill in my gaps when I have some.
Yeah, that sounds good, and I think what Christoph just said was really good. A way to think about it is that kind of like these are like the primary ways of paying. This is like the primary way of paying over Lightning. This is the primary piece of technology that's employed. The majority of Lightning pay, or like any Lightning payment, or I shouldn't say any, but I'd say the majority of Lightning payments, come from Bolt 11 invoices, and everything else listed on this page is some kind of way of trying to work around the limitations of this right here. It's trying to add some piece of functionality that's missing from that.
If you look at the contacts page that I was working on, where I posted that video earlier today, a lot of that is actually just trying to hide all of those things from the user to create a smooth UI where people are not really exposed to this as much, but instead can just pick somebody's name and face and press pay, and payment will go out.
Yeah, like this thing looks really overwhelming, everybody. But like I'm going to do a Figma hack here and paste the link of the Figma thing into so I can not reshare. Like the ultimate scenario, I think, is that like the user never sees this, and that like if they ever do see that, or if they ever are in a situation where like you feel like you need to, like on the transaction details, like show that, just do stuff like that, just abbreviate it. Like that's most of what the user should see, I mean, so yeah, that's all, this is all for machines to talk to each other as far as I'm concerned.
Patricia, did you want to say something?
Not really. I just accidentally hit it when I was trying to flash that thumbs up. I think that's like part of the problem is understanding this before you can even begin designing it. And I guess I would say to anybody else, I'm still like learning stuff all the time. It's still changing all the time. So it's hard to feel totally comfortable all the time. But you have me and Christoph and Steven, and we have each other. So if there's ever a question you have about this, you can always just DM us. We learn together,
Yeah, exactly. And the other good thing is if there's something all of this stuff, can help. It can allow us identifying where the tricky parts are. Can help us figure out what new pages should go in the guide, and then we can explain it there, and then it'll be super easy for everyone in the future.
Definitely.
Now,
And I think this is great, Stephen. Are we going to do this again next week too? Because
as long as everybody wants to,
every time.
yeah, as long as everybody wants to keep doing it, I'm happy to keep doing it.
Cool.
I think, yeah, I'll go ahead and put one on the calendar for next week, and I'll post about it in Slack, and just kind of like what Millie did. Maybe just post some ideas of things you want to talk about or discuss. That would help me out in terms of because I don't want to bore people with content they're not interested in learning. So yeah, definitely just let me know what you're wanting to learn about. And if I don't know it, I'll find someone who does.
Thank you so much, Stephen, for doing this. Really appreciate it.
Yeah, no problem.
Yeah, dude, thanks so much. It's really helpful.
I'm gonna stop sharing my screen now. All right, cool. Well, I think I'm gonna go ahead and kill that recording. Later, everyone watching on the YouTubes and the Bitcoin TVs.